Okay, so let's begin with section 2.1, which deals entirely with categorical data, right? So when we work with categorical data, remember that's any data that is names, labels, addresses, descriptors, right? So there may be a natural way to sort, so you can collect them at the ordinal level, or maybe we don't even have that. We just have the nominal level of measurement for these data. What I have here is a simulated sample of categorical data. Namely, these are descriptors of students hypothetical students at ARC, who are either first-year students, second year, third year, fourth year, or they are ready to transfer, meaning they're going to transfer next semester. So you'll notice that there are 4 rows, 4 columns, so that means there's 16 data values here. So I'm just going to write that down. So our sample size here, because this is a sample, is 16. That'll be important later whenever we are going to be ready for organizing these data. But you'll notice that if we want to sort them, sorting in this case meaning, so to sort data is to organize them by some organizing principle. So you could say, okay, put the first years together first, then the second years. So we'll decide that, or it might be given to us. So first year, second year, these are the unique kinds of labels that we can have, right? If we were talking about gender or racial identity, we would have unique identifiers or variables that these data values then fall under. Third year, fourth year, and transfer. There might be more, but these are all the ones that we have in our data set. So now that we have a sorting principle, right? We would then actually sort them, right? You can use technology to help you. So for instance, if you're using, let me use a different color here. So for tech, right, you might be using Excel, so the Microsoft Office tool. If you put all of these in a column, there's a tool that allows you to sort alphabetically or in other organizing principles, right? By hand, which isn't really tech, but you could sort by hand if you have a small enough data set. And there are other tools available to us. If you put them directly into TI-84, for instance, if you wanted to, it's not really preferenced here for categorical data, it would sort it for you once you go to use tables. But anyway, so once you've sorted your data, right, we're going to sort them into piles, which we kind of are doing here by sorting them into each distinct variable, which actually partitions our data already. But organizing this way isn't enough. What we usually want to do is we want to summarize our data, right? So data summarization refers to condensing our raw data. This is our raw data, raw categorical data. We want to condense our data in some way that still maintains the level of measurement. So the ways that we can do this, one common way is to use a table. And the way that we can use a table is we can count how many of each distinct kind of label there are. So let me illustrate, and then we'll get into what each one means. So I'm setting up 2 columns here for my table. one of them is labeled category and the other one is labeled count/frequency. Count and frequency are interchangeable, okay? But what this means is for each one of our distinct labels, right? So first, second, third, I don't have enough room here, but so I'll finish this on a separate sheet. But the idea is for each one of these unique identifiers or labels for our categorical data, we have to count how many times each one occurs in our data set. So just for the sake of illustration, I'll do this properly on another sheet here, but how many first year students are there represented in our data set? So I count 1, 2, 3, 4, just 4. So we put a 4 there, corresponding to the first year students. For second year students, right, how many are there? There's 1, 2, 3, 4, 5. How many third year students? Okay. 1, 2. And so on, until we finished going through our entire data set. You'll notice then that as we go on, each one of these labels should get counted once, exactly once. So properly though, what we're doing is we're setting up a frequency distribution for categorical data. That's what that table is called. So we have a category, or what we call class column, and we have a count, or what we call frequency column. Now, to finish up that example from earlier, I'm going to use class and frequency as our... We're going to be using these terms much more often than category and count. But category is helpful in this case because it helps us remember that we're actually working with categorical data. So remember there's first years, second years, third years, fourth years, and transfers. And we already said we found 4 first years, 5 second years, and 2 second years. 4, 5, 2. And if we go back and we count how many fourth years and how many transfers, I count 1 fourth year and 1, 2, 3, 4 transfers. Okay, so that's our frequency distribution, and you'll know that you did this correctly if when you add up the frequencies, you should get the sample size back. So if we add it up, right, so that's 9, 11, 10, no, 9, 11, 12, 16. That is our sample size. So we did this correctly, okay? And what we might write, notationally, we might say that the sum, this notation is called sum. You might want to review summation notation in the appendix. For each of our classes, so I'm going to use a subscript K, the sum of the frequencies, which we denote by F sub K. So these are just labels, right? We're saying we're adding up all the frequencies. That has to add up to the sample size. So that's how we know that the frequency table works, this frequency distribution. And that's not the only way that we can organize our categorical data. So frequency is helpful in we're actually sorting everything and compressing it into this table. But unless we're very clear about what the sample size is, or if we have a good sense of relative size, we might need to do something better. We might use something called relative frequency. And what that is we take each frequency as a proportion or a ratio out of the total sample size. So remember, this is sample size. I'm going to use words here. And what this does is this rescales our table so that we understand it in terms of proportions, percentages, ratios, right? So when you're using relative frequency, you probably want to round to the same precision. So typically we'll round to no more than 4 places after the decimal. You can do more than that, but I don't recommend it. So again, I'll set up our frequency distribution again, but I'm going to add a column. When we do the relative frequency distributions, we won't have the middle column necessarily, but you can if you want, if it helps you set it up. So now I'm going to have 3 columns here. So for my first year students, second year students, third year, fourth year, and my transfer students. Okay, and then so we said there were 4, 5, 2, 1, and 4. 4, 5, 2, 1, and 4. And so we'll bring that down again. And to calculate each relative frequency, we're going to compute that frequency divided by, remember, what was the sample size? We said n equals 16. So 4 divided by 16. And you can leave it as a fraction, or if you want to represent it as a decimal number, then you should actually compute that. Now 4/16, that's 0.25, because that's a quarter. But the rest, we probably will need some help figuring that out. So pull out your calculator, whatever you have. I am using my phone calculator because we don't need much more than that. Now 5/16, that's 0.3125. 2/16 is 0.125. And 1/16 is 0.0625. Okay. So each of these we're actually representing as so remember, no more than 4 places after the decimal. I added the zeros just for the sake of clarity and so that it all looks the same. So as you're working with the relative frequencies, remember there was that rule when we worked with just the frequencies that they have to add up to the sample size. In this case, because we divided each of them by the sample size, they should add up to 1, right? So you can verify using your calculator, as I'm doing right now. And sometimes you'll be a little bit off, just because, especially if you're rounding. If you round your decimals, then you might be off by 0.01 or something very small. But if you're not rounding, then it should be precise. It should equal exactly 1. And so with that, again, that rule that tells you that you did this correctly for relative frequency, we would say that the sum, remember this symbol, sigma, represents sum, over all the classes of the relative frequencies equals 1. So that's how you know you've done it correctly. And this will come back again in a later unit, but you will be able to use this not only with categorical data, but also with quantitative data. So we'll see that in a later video.